Okay, 13.3 exponential decay functions. We are on page 733. On 13.2, we did exponential growth functions, which we found out that they all had a curve and they grew exponentially really fast. Okay, so today's problems are all going to decay really fast. So they're going to look something like that. They're going to curve downward. Also, on your growth functions, we looked at 2 to the x power and 10 to the x power. Today, on your decay functions, it's going to be 1 over 2 to the x power and 1 over 10 to the x power. Now, if you'll look on page 733, over on the far right, at the two tables, if you put this in your calculator, 1/2 to the x power, you will see that the numbers, as they get bigger in your x's, as you move to the right when you're plotting points, then your y's will get smaller and get really, really close to 0 but never touch it. And so if we filled in this table, it would go 8, 4, 2, 1, 1/2, 1/4, and 1/8. What are they going down by each time? 1/2, because our base is 1/2. All right, let's look at the other table. Our 1/10 to the x power. We'll start out with 1,000. What do you think, without putting it in your calculator, the next number would be? 100. The next number would be 10. And 1, 1/10, 1 100, 1 1,000. This one is starting out way up here at -3. It's going way up here, and it's curving down drastically, getting really, really close to the x-axis, but never touching it. And I didn't start this one over here far enough to the left. It should have came more like this. Any questions on those two? Exponential decay. Turn to page 734 at the top. Both of our functions look similar to that. What's the domain of 1 over 2 to the x power? How far left and how far right does this graph go? It's all reals. What about 1 over 10 to the x? Domain is all reals. 1 over 2 to the x, what is the range? Y is what? Greater than 0. How about 1 over 10 to the x? Y would be what? Greater than 0. Same thing. These are like parent functions. Only the base changed. The end behavior, as x approaches positive infinity, what is y approaching? Here's our graph. As x comes down and approaches positive infinity here, as it gets more and more, bigger and bigger, what is y approaching? What's this arrow approaching? 0. That right there would be 0. What about on our 1/10 to the x? 0. Same thing. They're both going to be the same thing. in behavior when x approaches negative infinity. So here goes this way. What is y approaching when we're moving to the left of the graph? What is y approaching? Here we're moving to the left of the graph. What is y doing? Approaching what?
Positive.
Positive infinity on both of them. What is our y-intercept on both? It's the same as it was yesterday. Where does it cross the y-axis on both of them? 0, 1. Very good. 0, 1. So this was 0, 0. Positive infinity, 0, 1, 0, 1. Okay, we're going to go through the bottom, the predicting the transformations really quick because they're the same thing we've been doing all year long. Starting at the bottom of page 734. The graph of g of x equals 3 to the 1/2 x will be graphed on f of x equals 1/2 x. Vertical what? Vertically what? Stretched by a factor of 3. You can say it out loud. The graph of g of x equals 1/4. 1/2 to the x will be graphed of f of x equals 1/2 to the x. Vertical what? Compression by a factor of 1/4. The graph of g of x equals negative 3/4. 1/2 to the x will be graphed. The f of x equals 1/2 x reflected across the x-axis and a vertical stretch by a factor of 3/4. No, I'm on the wrong one. Did I skip one? I'm sorry, I did. This is compression by a factor of 3/4. The graph g of x equals negative 5, 1/2 to the x will be the graph of f of x equals 1/2 to the x reflected across the x-axis, a vertical stretch by a factor of 5. Graph of q of x equals negative 5/4 times 1/10 to the x will be a graph of f of x equals 1/10 to the x reflected across the x-axis, vertical stretch by a factor of 5/4. The graph of q of x equals negative 1/4 times 1/10 to the x will be the graph of f of x equals 1/10 to the x reflected across the x-axis and a vertical compression by a factor of 1/4. Questions on those? Anybody? Part C. The graph of g of x equals 1/2 to the x plus 1 will be the graph of f of x equals 1/2 to the x translated 1 unit to the left. The graph of g of x equals 1/2 to the x minus 4 will be the graph of f of x equals 1/2 to the x translated 4 units to the right. The graph of q of x equals 1/10 to the x plus 2 will be the graph of f of x equals 1/10 to the x translated 2 units to the left. The graph of q of x equals 1/10 to the x plus 2 will be the graph of f of x equals 1/10 to the x translated, oh, I read the wrong one. The graph of q of x equals 1/10 x minus 3 will be the graph of f of x equals 1/10 to the x translated 3 units to the right. Part D, the graph of g of x equals 1/2 to the x plus 3 will be the graph of f of x equals 1/2 to the x translated 3 units up. Graph of g of x equals 1/2 to the x minus 5/2 will be the graph of f of x equals 1/2 x translated 2.5 or 5/2 units down. The graph of q of x equals 1/10 to the x plus 5 will be the graph of f of x equals 1/10 to the x translated 5 units up. The graph of q of x equals 1/10 to the x minus 2 will be the graph of f of x equals 1/10 to the x translated 2 units down. Any questions on translations? Okay, we're going to go straight to page 737. We're going to skip this example right here. We're going to go straight to your turn. Alright, on all of these, we're going to make a T-chart like we have done all year long. On the left, the X, you're still going to go by what is with the X right here where it says X plus 2. It's going to be opposite of that, just like it has been all year long. It will be X minus 2. On your Y side, it will be the same thing. We're going to treat all of this right here with the X as the Y, so it will be 3Y minus 4. The exact same thing we've been doing. Your reference points will change every time. The first reference point will not. It will be 0, 1. Your second reference point will be -1, 1 over B. That's a B. 1 over B. Which means you'll take whatever's in here in the parentheses, your B, and you'll just flip it over. Because 1 over 1/3 really means 3. Okay, so your reference point here would be 0, 1 and -1, 3. This will be a 3 on this particular problem. So every time you have, let's say you had 1/6 to the x minus 4, then your reference point would be what? -1/6. Make sense? All right, so let's put these reference points in. If I put a 0 in for x, that will give me a -2. If I put a 1 for the y, that will give me a -1. What if I put a -1 for the x? -3. And if I put a 3 in for the y, I should get a 5. I'm going to plot those points. -2, -1, -3, 5. Where's my horizontal asymptote? How far down do I know to draw this graph here? What is my horizontal asymptote?
-4.
-4. Remember, it's whatever the K is. So my horizontal asymptote is at -4. So that's where I draw my line. I cannot cross that line. So my graph would come down. It would get really, really close to -4 and never touch. It would look just like that. What's my domain?
All right.
All reals. And my range, y such that what? Y is greater than -4. Any questions? All right, that example right there is like problems 1 through 11 is just like that. 1 through 11. Now look at your turn at the on page 740. Your turn on page 740.